Now, some people chose to multiply by y. That's fine if you wanted to do that as the first step, okay? You're still going to see that's not exact. So sine y over y minus 2e to minus x sine x dx plus y plus 2 plus x. Okay. Part A, show that this equation is not exact, okay? 5 points for that. Okay, as usual, we'll call that m, we'll call that n, okay? Well, we need the partial of m with respect to y, right? In this case, it's just with respect to y of sine y times y to the minus 1. Use the quotient rule. Notice how I did d by dy, right? Because sine y is only a function of y. And if you use the product rule, you'll get cosine of y divided by y minus 1 over y squared sine y. Or anything that's equivalent to that. Okay? 1 over y cosine y minus 1 over y squared sine y. Okay? And then we do the partial of n with respect to x. Okay? I go over there. Okay? I have a 1 over y I can pull out, right? And I differentiate respect to x. Cosine y, it's a partial derivative, so that's 0. All I need is the derivative of 2 dx cosine x, right? That becomes minus, this has a negative on it? Yeah. That becomes, be careful with those minuses. So you get minus 2 e to the minus x cosine of x, right? Differentiate minus x, cosine minus sine, and then I get minus 2 e to the minus x sine of x. Okay. So clearly not exact, right? So 5 points for that. Okay. The MDY is not equal to that. Okay? And like I said, I really can't understand those people who then started, they did things like, they looked at my minus nx over m. In part B, I tell you what the integrating factor is. Why are you making life hard for yourself? Okay? So show that mu, which is y e to the x, is an integrating factor. That means that if I take this original equation and I multiply through by y e to the x, it should be exact, right? So again, 5 points for that because it's the same thing, right? You just multiply by y e to the x, and then you do this business again. Okay. So what happens after we multiply through by the integrating factor now? Okay, you get rid of the y, and you get rid of those exponentials. And you'll get the following now. You'll get e to the x times the sine of y minus 2y sine of x dx. Right? E dx sine y minus 2y sine x dx plus e to the x cosine of y plus 2 cosine x dy is equal to 0. Okay, and I don't call this PQ or whatever you call it. That's my new m and my new n. Okay, now hopefully this should be exact, right? Well, let's take the partial of my new m now with respect to y. I get e dx cos y, right? And the derivative of minus 2y sine x is minus 2 sine of x. And if I take the partial of n with respect to x, where that of e dx cosine y, right? And the derivative of 2 cosine is minus 2 sine x. Yes, exact. So that's 5 points. Okay?
Professor?
Yeah, sure.
You crossed that. I use different letters for the differential m and n.
Yeah.
But I have dy over dx, and you crossed out on the bottom for when you have.
Well, let's show me after class, okay?
Okay.
Yeah, okay. Okay, so now it's exact. Okay. And now it's the usual business, right? Okay, because this is exact, we know basically that this expression is nothing more than du, and we know the formula for the differential of u, it's partial u partial x dx. So the du dx is now e to the x sine of y minus 2y sine x. And partial u partial y is my dy coefficient. which is e dx cosine y plus 2 cosine x. And they're both of equal complexity. What did I do? I integrated, I guess, first this guy. I integrated this guy first. Let's do that. Okay. Oh, let me talk about the credits on this thing. So 5, I covered that. Okay, so you got 5 points for the first part, right? We showed it wasn't exact. And 5 points over here if after you multiply through by the integrating factor, you demonstrate that it was exact. So that's half the credit already. And obviously the remaining 10 points is you're getting the solution to the equation. Okay, let's take the first guy and integrate that. And again, it's partial u, partial x. Okay, and again, people who wrote du dx, I crossed it out, you didn't lose credit. Okay, but I don't want you to get into that habit of, not differentiating, I guess, not distinguishing between a partial derivative and a regular derivative. So now I integrate this partial with respect to x, okay, and I get y. I have to integrate e to the x, that's just e to the x, sine of y, minus plus 2y cosine x, I guess, right? And again, don't forget the arbitrary function of y. Right? Because we integrated partially. And again, what you should do is stop and differentiate and check again. Partial u, partial x, e to the x sine y, yeah, plus 2 cosine x, okay? There's 2dx, that's like minus 2y sine x, and then the derivative with respect to x of phi of y must be 0, of course. It's a partial derivative with respect to x of the function only of y. And we know how to get the phi of y. We do partial u, partial y. What's going to happen over here? That e to the x sine y differentiates to cosine y plus 2 cosine x plus phi prime of y. And that must be exactly equal to the du dy over there, which is e to the x cosine of y plus 2 cosine x. Okay? And again, this is a check. Okay? Everything should cancel in the x variables. So now we get the derivative phi with respect to y is equal to 0. So phi of y is a constant, but since we're going to set u equal to a constant, we could just say phi. If you wrote down phi equals a constant, phi equals 0, it doesn't make a difference. You got credit for it. Okay? And then finally, the solution is what? U of xy equals constant. So the solution is e to the x sine of y plus 2y cosine x equals c. The c is an arbitrary constant. And obviously, this is a non-linear equation. There's no way we can solve this anything for y in terms of x. Okay. Okay, so like I said, you have, certainly if I made a mistake adding up points or whatever, usually if you look at your work and see how many points I've made a mistake adding them up or totaling the score, for sure see me about that, okay? But for other things, if you have, some, like, I said, if you have something which you think is, a legitimate concern, or you just not understand something, then also see me about that. Okay, I don't think we're going to do anything new today, okay? So we'll just get out a little bit earlier. Let me just tell you what's happening. We have the homework, okay? And I'm going to skip, I may come back to it, but what happens is that the next logical thing to do would be chapter 3, which is kind of just applications, but there's no new mathematics in that, so I may just assign that as independent reading or whatever, okay? Those are like some interesting problems, okay? But I really want to cover, more material than I did last semester, and I found that that was just kind of, unnecessary diversion, okay? We may come back to it if we have time, okay? All it is, you'll find if you look at section 3, it's just some problems that use the techniques that you've learned. Some is on population growth, some has to do with a mechanics problem, okay? I probably will do that one because this is, and of course, it's for ME, so I definitely want to do that one. But the next thing we're going to do is chapter 4, okay, which is on linear nth order equations, probably the most important part of the course, because in your other courses that you're going to take, be it circuits, heat transfer, whatever, the most common type of differential equation you encounter will be like a second order, if it's a mechanics problem, or for like strength of materials, For beams, you get fourth order equations, but they'll be linear with constant coefficients. And that topic, the linear equation, constant coefficients, we're going to attack the whole thing, okay? In other words, you'll be able to solve any linear equation with constant coefficients, no matter what the order is, okay? And because that theory has been developed, pretty much exhausted, so to speak. Okay, so I guess I'll see you guys on Wednesday.